So I want to do an example along the same lines of what we did, just a little bit more complicated. Um, so we have here is the function. We're going to integrate the function cosine to the fifth of 2x sine to the 38th 2x dx. So what we have here is basically just the same, just a regular, everyday typical function that preschoolers all across America are encountering when they wake up every day. So here's how we're going to do this. We're going to observe that, as usual, we look for the odd power if there is one. In this case, there is. So we can see that cosine to the fifth, cosine is being raised to an odd power. And this is the term that we're going to peel off one of. So let's rewrite this in this form. Let's rewrite this as the integral of cosine to the fourth 2x sine to the 38th 2x cosine 2x dx. Okay, so what we can see is that this is going to become part of our du term. So since the du term is going to have a cosine of 2x in it, we want the u term to have a sine of 2x. What that means is that in order to get this ready for u substitution, what we have to do is we have to take all of this and make sure that that instead of it being in both cosines and sines, we have to make sure the whole thing is in sines. This is how we're going to do it. Observe that this cosine to the fourth can be rewritten as cosine squared 2x squared, like that. So I'll then keep the sine to the 38th 2x cosine 2x dx. And now what I want to do is let me rewrite that cosine squared 2x. Recall that this identity is very, very important. So we're going to be able, the identity cosine squared plus sine squared equals 1 is very important. So we're going to be able to rewrite that, the cosine squared 2x as 1 minus sine squared 2x. And notice that it's still being squared, so I have to put a squared there. And this is going to be then sine to the 38th 2x cosine 2x and dx. And as everything that appears on the left side is going to have some sort of counterpart on the right side. You can't omit anything. You can't omit anything. So, oh, actually, yeah, let's do the u substitution now. Now that we have everything written in terms of sine, plus we have this cosine 2x dx at the end, we're ready to do the u substitution. So I'm going to write u equals sine of 2x. So that gives us du is equal to 2 cosine of 2x dx, and therefore 1 half du is equal to cosine 2x dx. So now I'm completely ready to do the substitution. We have here that this is 1 half du, this is u to the 38th, and this is now 1 minus u squared squared, like that. So I can now go ahead and just rewrite this in terms of u. This is going to be 1 minus u squared squared u to the 38th times 1 half du. Okay, so we'll continue along with this, and this becomes now, I'm going to take the 1 half and put it out here. What I want to do is I want to expand this term right here at 1 minus u squared squared, so I want to rewrite that as 1 minus 2u squared plus u to the fourth, and then I still have the u to the 38th, and I've taken the 1 half out, so I just have a du left over. Now, let's simplify this just a bit more. This is going to be, 1 half integral of u to the 38th minus 2u to the 40th plus u to the 42 du. So that becomes now 1 half u to the 39th over 39 minus 2 u to the 41st over 41 plus u to the 43 over 43. And we'll just go through a little bit more simplification. This becomes u to the 39th over 78 minus u to the 41 over 41, because that 1 half takes the 2 out. And then we have u to the 43 over 86. And so finally, since we know that u is equal to sine of 2x, I can finally do the back substitution, and that becomes sine to the 39th of of 2x over 78 minus sine to the 41st of 2x over 41 plus sine to the 43 2x over 86, and then of course the hardest part of the problem, the plus c. Let's draw a nice clean box around that, and there we go. So that's the answer. So here's a similar problem for you to think about. I'm not going to work this problem. I just want you to look at it and think about how would you break this down so that it can be evaluated by the techniques that we've used so far.